Kia ora. Hello from New Zealand. My name is Jens Brinkmann, and today I'm presenting the publication that my PhD supervisor, David Wynn, and I co-authored. Before we are going into the rather lengthy title, let me provide you with some background information. This topic is more or less my entire PhD, and internally we refer to it as the end-to-end workflow. The idea is, based on our own observation, backed by literature, and from empirical findings that we achieved, that practitioners, especially in engineering design, are facing more and more situations where they have to deal with preliminary or immature information. We decided to use the term maturity to refer to something similar to fruit ripening on a plant. We discovered that maturity of preliminary design information isn't something that you can easily express as one metric. You can't state this CAD file's maturity is a 3 out of 5. We encountered various terms related to maturity and aligned them in a taxonomy. Our taxonomy is hierarchically structured. On top is maturity. There are several perspectives. There are facets and subfacets. In this publication, we've only shown 5 subfacets. Currently, we think maturity can be captured by 17 subfacets. So we tried to apply the taxonomy to our own work and to judge our own work's maturity. We found that this is quite a challenging task. Therefore, for practitioners in reality, we want to provide eliciting schemes that help them. The scale was initially just the 3 traffic light colors, and then we added 2 in-between categories. Now let's assume that the practitioner has assessed the maturity of his CAD part. He has generated 17 or 5 values, and these have to be aggregated in a meaningful way. Given the time restrictions, I won't go into detail. For further details, please see the conference paper. But on a broad scale, we have compensating and non-compensating factors, and they have to be treated differently in order to create a meaningful aggregation. Now let's assume we went through all these steps and we have created values about different parts' maturities. We want to use them. We identified 2 relevant use cases: the development of insights and the visualization. The development of insights is based on a logic tree where each part is assessed, infused in part with DSM input and its maturity, and a penalty score is calculated to determine if you should start working on this part or not. For the visualization, we decided to use augmented reality, AR. For that, we need some physical object to overlay our data. Based on another publication, we found the mule concept, which states that you oftentimes have an outdated product version that you incrementally enhance, and we're going to use that for our AR visualization. Now I'm going to show you a video of our concept demonstrator, and afterwards I'm happy to take questions. Thanks for your attention. See you. As the app is started, guidance to an initial pose is provided. CAD files are downloaded. Based on their maturity, traffic light colors are overlaid. Let's flip it over to get a better view. An additional overlay is toggled, and a table showing the priority scores computed as per our method is shown. This concludes how we want to support practitioners' communication and decision-making by actively considering maturity statuses. Ultimately, let's have a look at the publication's title again. We have seen that assessing is based on the shown taxonomy and its practical applications supported by eliciting schemes. Ways of aggregating maturity subfacets, especially compensating and non-compensating, were touched upon. And for the visualizing aspect, we have seen the logic tree-based approach and the AR application. All of this is targeted at the maturity of preliminary design information, with the goal to support collaborative design.